we are saying that it is an equation with one which the variable occurs in the exponent. The variable occurs in the exponent. And some of the equation can be solved by using the method that we use when we are dealing with one-to-one function, if a function is one-to-one or not. You remember we looked at two different rules, right? All right, so these rules are that when you have two equations, right? If you have two equations, that the base, okay, before that, let's try to explain this. If you have, let's say B, you have B x, right? If you have bx, b, the name of b is what? The base, and x is what? Exponent. So if you have two different equations, okay, and they are equating to themselves with the help of equal sign, and they have the same base in the first example, if they have the same base, it means we can forget about the base and concentrate on the exponent, right? So for instance, if we have 2 exponent 3x is equal to 2 exponent 6, okay? 2 exponent 3x is equal to 2 exponent 6. But because the base are the same, we have 2 and 2, right? Then we can write only the exponent. So if you are writing only the exponent, then we are going to write 3x is equal to 6. And then we solve for x by dividing both sides by what? 3. And our x is equal to what? Our x will be equal to 2. Please, is that okay? That's the first part, okay? And the second part says that when you have an equation where the exponents are the same, when the exponents are the same, then let's equate the base. So let's use the same example, whereby we have 3x exponent 2 is equal to 6 exponent 2. You realize that because the exponents are the same, 2 here, 2 there, then we should forget about them and equate the bases. So the base is going to be 3x is equal to 6, and then we solve for our x by dividing both sides by 3, this by 3, and at the end we get x is equal to what? 2. So please, if you understand this two simple rule, then we wouldn't have problem solving this particular questions under equation, exponential equation. Right, now let's try to solve for the first question. Let's try with our first question. Since the rules are okay with us, let's solve with our first question. So the first question that you want to look at is number 1. When you have 3 exponent x plus 2 is equal to 3 exponent 5. Now let's say this rule is rule 1 and this is what? Rule 2. So which rule are you going to use, rule 1 or rule 2? And it's obvious, since the base are the same, then we go with what? Rule 1. And to solve this, we write, you can either write that since the base are the same, you equate the exponent, or you can just go ahead and equate the exponent. So let's write it. Since the base are the same, we equate the exponent, or you can write powers, the exponent. Okay, now, so our solution is going to be x plus 2 is equal to 5, and then we find our x. So x simply means 5 minus 2, and our x is equal to what? 3. As simple as that. Now number 2, when we have 2 divided by 3 exponent x is equal to 2 divided by 3 exponent 4. Okay, and now this is how you have to also write the equation. Since we have the same base, right, we equate the exponent because the base, this one is 2 divided by 3, this is 2 divided by 3, and they are the same, and we know that is the base. So let's equate the exponent. So at the end, we are going to get x is equal to what? 4. But please, for your work to be nice and to tell the examiner that you know what you're doing, just write the reason why x is equal to 4. And the reason is what? Since the base are the same, we equate what? The exponent. And we get x is equal to what? 4. Right. Now let's look at these try questions. Let's look at these try questions. So number 1, we are asked to solve for number 1, 2. Number 1 is 2 exponent x minus 1 is equal to 32. Now, you realize that we don't have the same base, right? So what we are going to do to get the same base is what we need to do, right? So the base for the left-hand side is, what? 2. So we are going to make sure that on the right-hand side, we are going to have a base that is also 2. I'm saying 2 on the left-hand side because that is the simplest number that you can ever have. Assuming we have this place to be 4, then we can consider another number to be the base. But since we have only 2 to be the base, let's consider the left side to be what? 2 as the base. On the right-hand side, we are going to change it from 32 to 2 exponents a number. 2 exponents a number. So 2 exponents, what number will give us 32? Then we realize that when 2 exponent 5, when you write 2 exponent 5, we get to 32. Then let's write. So we are going to write our solution as what? 2x minus 1 is equal to 2 exponent 5. And then that will take you back to the first rule. When the bases are the same, we equate the exponent. So equate the powers. As you can also write equate the powers because the powers is the same as what? The exponent. Then we write our final answer as what? X minus 1 is equal to 5. And x is equal to 5 plus 1. X is equal to 6. Right. So the trick here is you just change 32 to have the same base as the left one. Please, is that okay? You just change the 32 to have the same base as the left one. That's what all this is all about. Now let's look at question 2. Question 2 says that when you have 2 exponent x exponent 2 is equal to 2 exponent 16. Now, since the bases are the same, let's equate the powers. So we are going to equate the powers. Equate the powers or equate the exponent. Okay, so we are going to have x squared is equal to 16. And I know the moment you equate or you make the base the same or the exponent to be the same, then you should be able to solve the rest of the question. And we take a square root of both sides. So we are going to have x is equal to square root of 16. And x is equal to plus or minus 4. Please, is that okay? Right. Now, let's try to finish these questions first. And the next question is what? Question 3. So question 3 is 8 exponent 2x plus 1 is equal to 64. 8 exponent 2x plus 1 is equal to 64. So our solution to this question is going to be, make sure we make the exponent to be the same. So we are going to look at 2 ways of this. if it will help, whichever way that will help. So now the first way, we have 8 exponent 2x plus 1 is equal to 8 to what power or to what exponent will give us 64? And we know that when 8 multiply itself, we get 64. So we can have 8 exponent 2. And at the end, we can equate the exponents since the bases are the same. So we have 2x plus 1 is equal to 2. And then we find x by what? Factorizing or grouping like terms. So we have 2x is equal to 2 minus 1, and x is equal to 1 divided by 2. So when x is equal to 1 divided by 2, we get the left-hand side to be equal to what? The right-hand side. We can check this one. Check and see. So to check this, 8 exponent 2 and x is 1 over 2 plus 1 is equal to 64, right? Now, 2 will cancel 2 and we have 1. 1 times 1 is 1, so 8 exponent 1 plus 1 is equal to 64. And we know 8 exponent 2 is equal to 64, and the answer is what? Correct. And if you are given in examination, you don't need to write this one out. You can just do this on your own just to confirm your answer if it is correct or not. Is that okay? All right, now let's look at question 4. So question 4 says that 1 divided by 2 exponent x is equal to 64. Yes, this was the second part that I wanted us to look at, and we are having it here. So let's solve this one. When we have a question like this, you know, anytime you have a fraction, you can write the fraction back again without getting, you can write the fraction back in a negative way because we looked at inverse previously. So I believe this shouldn't be a problem here. So how do we write 1 divided by 2 exponent x? This can also be written as 2x. This can be written as 2 exponent minus x, right? 1 divided by 2x is the same as 2 exponent minus x. 2 exponent minus x, and then should be equal to, the base is 2, so 2 to what exponent will give us 64? 2 to what exponent will give us 64? And if you know it, you realize that 2 to exponent 6 will give us 64, right? And then because the bases are the same, we just equate our exponent. So minus x is equal to 6. But you cannot write your answer, your final answer, in the form of what? Negative. So just multiply or divide both sides by what? Negative 1. So you're going to have x is equal to minus 6. Right. Now let's look at the last question. The last question, question 5. Where should we write our question 5? Okay, let's write it here. Question 5. Our question 5 says that 27 exponent x plus 1 is equal to 1 divided by 9. Now, how do we solve a question in this format? The first thing I want you to do is write it from fraction to a whole number, right? So let's just maintain the left side. 27 exponent x plus 1 is equal to, this can also be written as 9 exponent 1. 9 exponent 1. Right. So now let's try to change them because we know 9 exponent 2 will even give us what? 81. So on the right side at the end, we cannot have a common base of what? We cannot have a common base of 9. Please listen to this again. Mostly, if you look at all the questions that we solve, when the bases are different, like this one, the base is 8 and this side is what? 64. We looked at the smallest number, which is 8, and we use it to be the base for both. This one, we have base of 2 and base of 64. We took 2 to be the base on the both sides. This one too, you realize that all the questions that we solve, we normally take the smaller number to be the base for both sides. Now look at this question. It's quite unique because the numbers, we have two bases, 27 and 9, right? but the smaller one, which is 9, can never be the base for both numbers. Because even if you want to use 9, 9 squared is 81. So it will not be possible. So we are going to look for a base that will be common for the two of them. The easiest way is to look for 9. What will be the base for 9? And we can go by 3, right? So 3 to the power 2 will give us 9. Now 3 to the power what will give us 27. Then we realize that 3 to the power 3 will give us 27. So you're going to have 3 to the power 3 will be 27, the same as 27. Okay, and then our x plus 1 will be given as this. Then it's equal to 3 to the power 2 times minus 1. Please, is that okay? I've put in this into the bracket for it to represent the whole numbers over there. So 3 to the power 3 will give us 27. And outside the bracket, we have our exponent, the usual exponent. And on the right side, 3 to the power 2 will give us 9. And outside, we have our minus 1. So now let's try to multiply or consider only the exponent, since the denominator, the bases are the same. From here, you can either expand the exponent and equate the bases, or just equate the exponent. But please, if you are equating the exponent from here, just be careful, because don't forget to write all the things out. So we equate the exponent or the powers since the base are the same. So you're going to have 3x plus 1 is equal to 2 minus 1. Is that okay? Or from this side, we can also write it as 3 exponent 3x plus 3 should be equal to 3 exponent minus 2. Then you equate the exponent. And when you equate the exponent, you're going to get 3x plus 3 is equal to minus 2. And then 3x is equal to minus 5. X is equal to minus 5 divided by 3. Now let's look at this one. What are we going to get from here? So this is 3 times, we expand the brackets. So we are going to have 3x plus 3 should be equal to minus 2. 3x is equal to minus 2 minus 3. 3x is equal to minus 5, and our x is equal to minus 5 divided by 3. You see, you get the same answer. Whichever way you want to use, either this one or that one. Whichever way that you want to use, you get the same answer. So just know your way out. Please, is that okay? All right, so let's meet in the next class to look for how to solve exponential equation when the equation is in a quadratic form.